Welcome to science class. Today we will be going on a tour of some of the moons of our solar system. Moons are just as diverse and amazing as the planets themselves. There are 7 moons larger than Pluto, and 2 larger than Mercury. Some moons have oceans, geysers, volcanoes, atmospheres, lakes, rivers, snow, perhaps even life. Let's get started. Here's a question that's harder to answer than you think. What is a moon? For the longest time, we only ever knew of one moon, this one. The first moons outside of Earth ever known were Jupiter's 4 largest moons, discovered by Galileo. But Galileo would not have called them moons. At first, he thought they were stars. Then he realized they were orbiting Jupiter. Truth is, Galileo only saw tiny specks of light. He had no idea what they really looked like. Galileo called these objects the Medicean planets, but remember, planet meant wandering star in that time. The word satellite is synonymous with modern science and space exploration, but the word is thousands of years old. Any object that orbits any other object can be called a natural satellite, whether it's the size of another planet or just a speck. So how big does something have to be to graduate from satellite to moon? Does Saturn have billions of moons? Every speck of material in its rings could theoretically count. People hear that and they think, oh, don't be stupid, those aren't moons. Once again, we are used to our moon, which is spherical. But if a satellite has to be spherical to be a moon, then Jupiter only has 4 moons, not 79. Here's a picture of one of these 75 non-spherical moons. Whatever your idea of what a moon looked like before you started watching this video, I bet that wasn't it. So in all honesty, here's what a moon is. We don't know. Yeah, seriously, it's just a term we use to describe some of the objects that orbit a planet, and we don't have any other qualifications. For some reason, we don't say the individual particles in Saturn's rings count as moons, and nobody seems to care. This is exactly what happened to Pluto, which we will talk about in the next video. Here's another hard question. Are planets the only things that have moons? Ida, a 60-kilometer long by 25-kilometer wide asteroid, has a small satellite named Dactyl, only 1.4 kilometers across. So what is Dactyl? And it's not just Ida, 76 known objects in the asteroid belt have satellites. The solar system is a complicated place. If we go with just the 8 planets and include the moons of dwarf planets, there are currently 182 known moons in the solar system. All but about 30 of these moons are less than 10 kilometers across, so the vast majority are nothing but asteroids that happen to orbit a planet. We are just going to look at 8 moons and very briefly bring up 2 others, and only from the planets Earth, Jupiter, Saturn, and Neptune. We're going to begin with the moon. Earth's moon, which you can call Luna, but I will just call the moon, is in a way a fragment of Earth. I brought this up when we looked at the geologic timescale of Earth. 4.5 billion years ago, a planetesimal likely struck the Earth, and the collision blasted away Earth's outer shell. This material accreted into the moon. To be clear, we do not know, nor could we ever know with 100% certainty that this happened, but it's the best hypothesis based on the evidence we have. The density of the moon is practically identical to the uppermost layers of Earth's crust and asthenosphere, which are exactly the layers in this hypothesis that would have been blasted away and formed the moon. If the moon formed in our neighborhood independently of the Earth and was captured by the Earth, then its density should be very similar to Earth's, because it formed in the same region using the same materials. Our next closest neighbor, Venus, after all, is extremely similar to Earth in density. But that's not what we find. Chemical analysis of moon rocks brought back by Apollo missions also revealed that the moon rocks have an almost identical chemical signature to Earth's surface rocks. The moon has dark terrains known as maria. One of them, known as the Sea of Tranquility, is where Apollo 11, the first manned mission to the moon, took place. These maria are crystallized lava beds. Weirdly, the lunar maria only exist on one side of the moon. The side of the moon that always faces away from Earth does not contain maria. The reason lunar maria are only present on the side of the moon that always faces Earth may be that the moon's surface stayed hot and molten much longer on that side. We know that the moon gets farther away from Earth every year. When the moon first formed, it may have been as close as 24,000 kilometers away. Right now it's over 380,000 kilometers away. Being so close to the still molten Earth may have kept the Earth-facing side hot enough to sustain these lava beds. But again, we're not really sure. The way the same side of the moon always faces Earth is known as tidal locking. Almost all large spherical moons are tidally locked by their host planet's gravity. Pluto and its largest moon, Charon, are tidally locked to each other. The first man-made object to ever reach the moon was called Luna 2, and it was launched by the Soviet Union. It reached the moon on September 13, 1959. This was not a mission to study the lunar surface. In fact, it hit the moon at 12,000 kilometers per hour. The point was just to be able to get something there. But a little bit of data on Earth's Van Allen belts and a few other things along the way was recorded. The Apollo missions by the United States are the only missions to land people on the moon. Apollo 8 was the first manned mission to orbit the moon. When they came around the far side of the moon, they saw something they weren't quite ready for, an Earthrise. Earth appeared over the horizon of the moon, and William Anders snapped this image of it. Everyone that had ever lived or died until that point was in this picture, except the astronauts. Humanity had never seen something like this before, not even close. It has often been credited as a major reason behind the celebration of the first Earth Day in 1970. The first mission to land people on the moon was Apollo 11. Launched on July 16, 1969, the Eagle touched down on the moon 4 days, 6 hours, 46 minutes, and 4 seconds later on July 20th. Neil Armstrong was the first to touch the surface of another celestial body in space, then Edwin Aldrin. Michael Collins had to stay on the orbiter. The last mission that ever landed on the moon was Apollo 17 on December 11th, 1972. Only 12 people have walked on the moon. 2 more astronauts would have, but Apollo 13 famously had a malfunction and they had to orbit the moon and return. And while 3 astronauts have flown to the moon twice, nobody has landed or walked on the moon twice. Apollo 11 spent just 21 hours and 31 minutes on the moon, while Apollo 17 spent over 3 days on the moon. Did we gain anything from being on the moon? Beyond some knowledge of the moon? Not really. But the technological advancements made in pursuit of going to the moon have carried over to other fields of science and to the public. We're going to take a look at 4 of Jupiter's moons next. All 4 of the Galilean moons have diameters greater than 3,000 kilometers. The next largest moon on Jupiter has a maximum diameter of about 400 kilometers. The 4 Galilean moons orbit between 422,000 kilometers to 1.88 million kilometers away from Jupiter. We're going to go in order of size, and Ganymede is up first. Ganymede is the largest moon in the solar system in terms of diameter and mass. It's 389 kilometers wider than Mercury, but only 45% the mass of Mercury. This is because virtually every other spherical moon, besides the Earth's, is made of ices and minerals, with very few metals. Ganymede's density is not even 2 grams per centimeter cubed. While its volume is much larger than our moon, its mass is only twice that of the moon. Ganymede has a magnetic field, the only moon which does, so there's likely some kind of metallic core, but very small. Ganymede's surface boasts highly distinct bands of light and dark. The dark bands are fairly heavily cratered, while the light bands have much fewer craters. The light terrains are distinctly grooved as well. It's not really obvious how these different bands develop, but the more recent lighter terrains may be tectonic in nature. Not plate tectonics, but water and ice perhaps. A fair amount of Ganymede's surface is water ice, and below may sit a vast liquid water ocean. As this water moves around, it may break apart and resurface Ganymede's exterior. Callisto is Jupiter's second largest moon. With a diameter of 4,820 kilometers, it's only 58 kilometers smaller than Mercury, but only 1/3 the mass. Callisto's density is 1.83 grams per centimeter cubed, and is composed of close to 50% ices and 50% rocky minerals. Taking 16.7 days to orbit Jupiter, Callisto is the farthest away of the Galilean moons, orbiting at nearly 1.9 million kilometers away. Callisto's surface is the most ancient and heavily cratered surface in the entire solar system. One of the impact craters, Valhalla, is huge, and you can see how it sent ripples across the relatively weak surface. The surface of Callisto does not break apart or reform in any way. Still, there very well may be liquid water trapped beneath a thick icy crust. Io is the most dense moon in the solar system, and the most volcanically active object in the entire solar system. There are no impact craters at all on Io. It is covered in hundreds of volcanic calderas that erupt regularly. Because of the weak surface gravity on Io, plumes of eruptions have been recorded at 500 kilometers tall. The molten material that erupts on Io is predominantly made of sulfur compounds. Io doesn't have an atmosphere, so its surface is not hot despite all of this volcanic activity. In fact, when large plumes erupt, the sulfur dioxide particles crystallize in the frigid emptiness of space and then fall back to the surface as snow. Io is about 300 kilometers wider than our moon, but that is still far too small to maintain tectonic activity in its mantle. So what allows Io to be active are tidal forces. Io is the closest Galilean moon. It also exhibits what's known as orbital resonance with two of Jupiter's next closest Galilean moons. Io orbits twice for every one Europa orbit and 4 times for every Ganymede orbit. As Io passes these moons, their mutual gravitational attraction pulls Io in the opposite direction of Jupiter. This can cause the surface of Io to bulge as much as 100 meters. If you bend a paperclip until it breaks, and feel the point where it broke using your lips, which are very sensitive, you can feel the warping causes a great amount of heat. Thus, we have a source for continuing tectonic activity in a moon that would otherwise be solid. There are even isolated mountain peaks on Io taller than Everest. There are no faults on Io, so it's not well understood what forms these mountains. Io is named after a mortal woman that Zeus transformed into a cow because he and his wife Hera were having a fight. The source for that fight was probably Zeus having an affair, because that's basically what Zeus was doing all the time. The smallest of the Galilean moons, Europa, is just about the most tantalizing place in the solar system. There are very few craters on Europa. Europa's surface is fractured all over the place. While Europa itself is the third most dense moon and is likely composed almost entirely of silicate minerals, the surface is composed almost entirely of water ice, 15 to 25 kilometers thick. A liquid ocean, perhaps 60 to 150 kilometers thick, almost certainly breaks apart and resurfaces Europa's surface. Europa is estimated to contain twice as much water as Earth, perhaps more. It is destination number 1 for scientists to search for life beyond Earth. The Europa Clipper is a planned mission to orbit Europa, flying as close as 25 kilometers above its surface to investigate the properties of the moon. Europa is only 354 kilometers short of the diameter of our moon. Europa is the smallest Galilean moon, but 6th largest moon in the solar system. Here's a pretty astonishing fact that highlights how most moons are much smaller than you think. Europa is more massive than all of the 175 moons smaller than it combined. Because of Europa's water ice exterior, if we replaced our moon with Europa, it would shine 5.5 times brighter. Tidal forces acting on Europa could very well be the source for its proposed interior ocean. Like Io, Europa is in orbital resonance. As it passes Ganymede, its interior could flex and provide heat, which maintains liquid water deep below the surface. We're going to travel out to Saturn next and investigate 2 of its moons in detail. We'll begin with Titan. Titan is the 2nd largest moon in the solar system. It's almost 1,700 kilometers wider than our moon, 270 kilometers wider than Mercury, and 113 kilometers shy of Ganymede's diameter. Like most other moons, Titan's density is very low, less than 1.9 grams per centimeter cubed. Despite being 3.25 times larger than our moon, it is less than twice the mass. Christian Huygens discovered Titan on March 25, 1655. Much later in 1944, Gerard Kuiper discovered that Titan has an atmosphere, and a substantial one. Although Titan is quite a bit smaller than Earth, its atmosphere is 1.5 times the mass of ours. Like ours, the majority of the atmosphere is nitrogen. The impenetrable yellow haze of Titan's atmosphere comes from small amounts of methane. The amazing thing about the atmosphere is that it is dynamic. Methane and ethane evaporate and condense in Titan's atmosphere, where it then precipitates onto the surface. Rivers, canyons, and lakes exist on Titan, carved by flowing methane eroding away permanently frozen water ice. No other places in the solar system have dynamic liquid activity and weather besides Earth and Titan. With the atmosphere being more massive, the atmospheric pressure on Titan is greater. You'd feel the same pressure on your body as you would being under about 15 meters of water on Earth. Because Titan is much less massive than Earth, the atmosphere is not pulled down with nearly as much force, and so it extends several hundred kilometers upward. But get this, because of the very dense atmosphere but weak gravity, if we placed you on Titan and protected you somehow, you could fly. Yeah, seriously. We would have to outfit you with wings of some sort, but the air is so thick and the gravity is so weak that you could keep yourself aloft in the air without much effort. Excluding crash landings, humanity has only ever landed objects in 7 places outside of Earth: Venus, the Moon, Mars, 2 comets, 1 asteroid, and Titan. The Cassini spacecraft, launched by NASA, carried a probe designed by the European Space Agency named the Huygens probe. On January 14, 2005, Huygens parachuted down to the surface of Titan to see what was there. The dark and ragged terrain looks like a desert landscape on Earth. The hills and valleys are sculpted out of water ice. Dark dunes were seen, but not made of eroded water ice, but hydrocarbon compounds. Drainage channels as well as large rivers were spotted on the surface, eroded by flowing methane. The rocks that you see are water ice boulders. There are several huge lakes of methane in Titan's northern hemisphere. The largest, Kraken Mare, is bigger than the Caspian Sea, which is Earth's largest inland body of water. Titan's surface is hard to study because of the atmosphere, but hardly any impact craters at all are known about. The shorelines of Titan's lakes always change, so we know the surface changes regularly. Saturn does not have any moons comparable to Titan. They're all much smaller, but they are still interesting in a number of ways. Mimas is only 396 kilometers wide, and it is the smallest object in the solar system that has a spherical shape. William Herschel, who discovered Uranus, discovered Mimas, as well as 3 other moons. But I really only bring up Mimas because it looks like the Death Star. Tethys has a density less than that of water, and a 400 kilometer wide crater. Enceladus is another very small moon, just 500 kilometers across. To me, it's the most beautiful moon. Its entire surface is snow and some exposed ice. Color enhancement reveals where the snow is thin and water ice is close to the surface. Enceladus is the most reflective object in the solar system. Enceladus's surface breaks and liquid water flies off into space, instantly becoming ice and vapor in gigantic plumes. This ice creates Saturn's outermost ring, the E ring. Enceladus is small, so the source for its liquid water is mysterious, but perhaps hydrothermal vents exist below a mantle of liquid water below the surface. Yet another fair candidate for life. The final moon we will explore is Triton, Neptune's largest moon, and named after the son of Poseidon. If you haven't caught on, while all planets except Uranus are Roman named, moons that are given mythological names are virtually all Greek. Triton is the 7th largest moon, and like Europa, it is more massive than all other smaller moons in the solar system combined. In fact, Triton is well over 1.5 times more massive than Pluto. Pluto kinda sucks. While Triton is similar in size to Europa, it is far less massive because it is about 50% less dense, at a little more than 2 grams per centimeter cubed. Triton is extremely far away from Earth, and it has only been glanced at very close once, by Voyager 2. Only around 40% of its surface was seen. We saw that its cantaloupe-looking surface has virtually no impact craters. This cantaloupe texture is likely the result of nitrogen ices flowing over the surface as glaciers. Triton was found to have active geysers, making it one of only very few geologically active bodies in the solar system. Triton is also the only large moon in the solar system that orbits its host planet clockwise, and we don't know how it happened. Next time, we are going to take a look at the asteroid belt, Kuiper belt, Oort cloud, and dwarf planets. Thanks for watching.